Well, hello everyone, welcome back guys. Hope you all are doing well. This is Mohammad Badruddin and today we are going to solve lab number 12 from web cache poisoning vulnerability module. I actually forgot to solve this lab and I directly solved lab number 13, which was the final lab. So someone asked me about this lab and once I revisited, I see that I missed that lab. So today I'm going to record this lab and hopefully we will solve this lab. So before going further, this little disclaimer as always for you. This video and its contents are only for educational and awareness purpose and I do not support any unethical or illegal act. That's been said, let's go and we see what this lab is all about. So this lab is about cache key injection. This time we are going to inject a cache key. So this lab is the standard of this lab is expert, and the agenda of this lab is like this lab contains multiple independent vulnerabilities including cache key injection. A user regularly visits this site's homepage using Chrome browser. Fine. So the difficulty of this lab is hard and it is expert level lab because there are multiple vulnerabilities we need to identify to solve this lab, and a regular user visits the homepage of this site after every 1 minute or 2 minutes. So we will see that. To solve the lab, combine the vulnerabilities to execute alert 1 in the victim's browser. Fine. And there is a notice. Once you go and try to solve this lab, you will see the notice or the note that you will need to make use of pragma. This is the request header. We will use this header to actually see whether the server or application is vulnerable for web cache poisoning or not. And the value we will use is x get cache key. So we need to use this header in order to solve the lab. Fine. I already written here some payloads which we will use, and before going to solve this lab or before going to this step, I am going to explain these payloads a bit here, because once we try to solve this lab and once we try to use these payloads, at that instant if we make too much delay while solving or while putting these payload, maybe we will get the missynchronized time between two requests, because here we will feed this payload in two requests. So if the time is mismatched, then maybe the user who is visiting home page again and again, so maybe we also miss that user, because the time when this user or the victim user visit the site's homepage, at that instant both of these requests must be valid. I mean that your malicious payload must be feeded or poisoned in the cache. Okay. So I already open up the Burp suite here. Let me just refresh this site so that it's not get expired. Fine. I already open up Burp suite here and I already did some homework so that we do not take too much time to solve this lab. So once I refresh the home page of this site, these are the requests. Okay, so this is the main request which redirect us to where, which redirect us to this location, and once we go to this location, it's again redirect us here. There is a very less difference or very minor difference here in these two requests. So if you see the URL here, you will see there is no slash here. There is no slash here, just a question mark, right? And it's redirect us to a place where it has the endpoint or complete URL with the slash. So, and here we have this response, and within this response it is trying to load one resource from the server, and the resource is js/localize.js, this resource. So if we come here and we scroll down, you will see here this resource is going to be load here. Yeah, this one source is this. Fine. So you just need to take care about this. because we will use this one in our payload, right? And it's going to call it here. Fine. So what I did, I come here and I just go to click, I just right click and go to extension, go to parameter miner, guess parameters and guess get parameters, right? And rest of the things leave default and make it okay. So I already did it, and here we have the result. So if we scroll it up, you will see what parameters are there. So some issues found, and what issue is there? Issue is for web cache poisoning, query parameter blacklisted. So the application excludes certain parameters from the cache key. This was confirmed by injecting the value. This is the value using the parameter UTM_content. Okay, and then replying the request without the injected value and confirming it still appears in the response. Okay, we already did it before in the previous labs, so I'm not going to explain it again. I hope you also watched those videos. So as you can see here, it's using UTM content. Fine. And with UTM content, it's also using other parameters, and also there is one more request header we can use, which is origin, right? So if we come back to the proxy and go to this request, you can see there is no origin. There is no origin. But if you go here in the extension, you will find that you can also use origin header. Okay, and we can use UTM content. Okay, because the application excludes certain parameters. Which parameters? UTM content parameter. So let's see. I'm going to right click and send this request to the repeater. Go to the repeater, and yeah, before going further, I'm just going to describe this one. So here what actually I'm doing, this is the clear text value. Okay, so the origin, as we saw that we can use the origin header. So in the request we will use origin header, and its value is something like X or whatever you want, and the content length is 8. Why it's 8? Because the number of characters in this payload, which is going to be alert 1. So if you count it 1, 2, 3, 4, 5, 6, 7, 8. So content length is 8. Okay. When we start HTTP request smuggling, we will see this one, CLTE, which is content length and transfer encoding. We will closely understand this one, but here you can understand it like content length is 8 because the payload here alert 1 has contains 8 characters, right? And these dollar signs, you will see this in a minute when we will use the pragma request header with X get cache key value, right? So we will use this one with what? With actually with this. Where is that request? This one. So I'm going to copy this and back here, and we will use it with this request. Okay, but here we will have to change few things. Like what? Like first of all, as we saw in the parameter miner result, that we can use UTM content, and let's say UTM content value is anything. You can say it X, Y, Z or anything you want. Then this is the second parameter, which is coarse. Okay, that is going to be cross origin resource sharing. Its value is by default from the server, it comes 0, but we will manipulate it to 1, and then we are going to say X is equal to 1. Okay, so we will use this request with the get, and within the same request we will also use origin, right? So first of all, we go with this, then we will try this request, and what this request is all about, you can see it's same what we put here. So here what we actually trying to do, we are trying to pass the request headers within the URL. That's what we are trying to do. Okay, and this results actually once the request go to the server or to the cache will break it and break it in this form. So it will see like this. It will consider this total URL like this, and this is considered as a request, and rest of the request headers and other things will be considered or ignored, and it will be considered because this is going to be the first content in your request, right? So this is the thing, and you will understand it more better once I'm going to solve this lab. So let's go it without wasting time. I'm just going to refresh it one more time, and yeah, lab is still active. Okay, so I send this request to the repeater, send this request, fine, everything is okay, missing, and location is this. So the difference is here there is no slash and there is slash, and you can also follow the redirection, so you will see the 200. Okay, now the thing is we need to use here after user agent, let's say pragma xget cache key. Okay, send this request again, and here you will see something. Let's see. So you can see here x cache key is /login, the same URL here, but you see here these two $signs, and this is the place. If you see this, that means the server is vulnerable for web cache poisoning. So first of all, you confirm this by putting this pragma header. Second, what you found from the parameter miner, that we can also use get parameter, which is UTM_content, and any value we can use. So let's say X, and then one more thing before going to put this, one more thing I want to show you. Let's say anything X, or let's say cybersec, fine, send this request. It's still coming from the cache. This is not the request what we are trying to make. 29, 30, 32, 33, 35, 0. And here, as you can see, our get parameter UTM content is appearing here. Now if we follow the redirection and let's try to search cybersec, so here you can see it's appearing here in the canonical reference link, and if we scroll down you will see one interesting thing, that this source is now manipulated. Okay, but the thing here is the cross origin resource sharing is blocked by 0, so we will make it 1, what I did it here. Okay, score is equal to 1. Fine. Little tuning I want to do with my Burp suite. If you are using the new version of Burp suite, as I am doing, I'm using the new version of Burp suite community edition 2023.3.3. I think this is the latest version. The tuning you need to do is like, it's using HTTP version 2, but we want to make it HTTP 1.1. If you try to solve this lab with HTTP version 2, maybe you will face a lot of problem as I faced before. So I'm going to make a bit changes here. So first thing, you can go to the repeater tab, click on repeater tab and enable HTTP 1 connection reuse. Okay, and we can disable this one, or no problem if you leave it enable, but make sure enable HTTP 1 connection reuse must be enabled. The second thing is go to the inspector and go to the request attributes. There are 2 attributes, and protocol is used by default HTTP version 2, but I want to use HTTP version 1. Now as you can see, as I click on HTTP version 1, this will automatically change. So just click it and yeah, it's changed. So now it's fine. You are not going to see a lot of difference here in the response, but it will have a big impact because in HTTP version 1.1 and 2 there is a huge difference. So let's see, go back to our this one and HTTP version 1. So that's it. Now what I'm going to do here is I'm again going to right click on this request and send it to the repeater, because I'm going to use 2 requests simultaneously and feed this URL and this URL with origin header and with the pragma request header. Now the thing is, the vulnerability, as I mentioned, that if we what we observe up to now here, okay, so that means this one, or you can say this request, okay, so this resource or this reference is actually vulnerable to header injection, and the header injection is going to be header injection we are going to exploit by putting origin header, as we see here. The second problem was parameter pollution, which we already solved one lab with by exploiting parameter pollution and through the UTM content, right? So there are multiple issues with this application as mentioned here in the description of the lab. So now let's go, we are all set and let's do it. So first of all, this is going to be your request, so I'm going to copy it, come back here, not this one, this was the request, so I'm going to put it here, okay. Protocol must be HTTP 1.1. The second thing is origin header, so I'm going to take this one. And one more thing I want to mention here, if you see this, where is it? Yeah, if you see this one, you will find here there is no URL encoding. There is no URL encoding, and that makes it more vulnerable. Fine. So let's go HTTP 1.1. Fine. Come back here. Copy back, paste it here. Second thing, take this origin, copy that and put it after host, paste that here and leave this pragma header, okay, because with this we know that the application is vulnerable. Okay, so this is the first one. I'm just going to send this and let's see what happened. So what we did is we are going to set the alert through this resource, right? And we are using UTM content, its value, anything you want, but the cross origin resource sharing must be 1 and x is equal to 1. This you can put anything, okay. And here in the header, in this origin header, actually we put another request headers that make this request separate. So here you will see we will get the alert one. So just send this here, yeah, fine. And now the X cache key value is this, fine. So this is the first thing. Now we poisoned this one. Let's go to the second one, come back here, and this time we are going to choose this. This is not much difference, everything is same. We just put what? We just put the origin header with the content and alert in the URL. Here we are passing the headers in the URL. Fine. From here I don't want pragma. Okay, origin is not here, just this one. So let's just send this, hope for the best. Let's see. Yeah, it's showing it here, and it's sending us 302 here. Now how you will test this? We can test it by coming here. If we click on home, you see this one. Before it's sending us here, yes, that's you can see here. Now it's sending us to our or hacker's intended path where hacker wants to redirect the victim. Fine. So if you see this, that means you are on the correct way. So come back here again, send this request, and make sure HTTP 1.1 you are using. Send this again. Follow redirection. Fine. 18. Come back here. And yeah, solve the lab. Now if we try to go to home page, we should have alert here. Just wait a moment because it's already here. I'm going to I just want to show you the alert. Let me check one more time. Maybe the request is timed out. This is our request. This is our request. Yeah. And come back here, send this again. No. Let it pass 16 seconds. 18, 20, 24. Make sure this one also in the cache. So both of these requests must be in the cache. Okay. Now this is actually the problem. Come back here. Let's see. Home. This is the problem that makes this lab more difficult, because both of these requests must be in a time frame. Okay, this is our request and the age is 0. Now it is in the cache. Let's try this one. Now you see this is the genuine request and the age is 6. That means there is very less difference in between both of these. So once this one is going to expire, this one comes into the picture, and once this one is in the cache, this one is going to expire. 31, 33. Okay, age is 5. This is good. Age is 8. This is good. Now if I try to go home page, we should see alert. Yeah, that's it. So that's it for this lab. Hope you like the content. If you like the content, please like, subscribe and share. If you have any query, please put your query in the comment section. I will try to respond as soon as possible. And really very thank you to all of you guys for appreciating and giving good comments. See you in the next video, and we will start the HTTP smuggling module. Bye.